All right, we're at the so-called finish line, right? So yeah, thanks so much for having me, for inviting me to come speak, and congratulations on another successful DevOps Days. I go to a lot of these. I organize one in Denver, DevOps Days Rockies, which is coming up in just a few weeks. So I love these things, and it's awesome to always be a part of it everywhere I go. So this talk is called Beyond the Mean Time to Recover, or the Mean Time to Repair, Mean Time to Resolve. Lots of different ways you can say that. But for the rest of this demonstration, for the rest of this presentation, we're going to just say the mean time to recover. This is me. I work at VictorOps. VictorOps, you probably heard the 1-minute pitch earlier. We are incident management, on-call management. Those who are on call, you probably use something like us, or you are using us, hopefully to make on-call suck a little bit less. And a good portion of what I'm going to be talking about today is directly related to that sort of role and that responsibility of being on call and trying to keep systems up and running. How many have read this book here, Site Reliability Engineering from O'Reilly? No, not that many. It's actually really, really good. It's very thick. It's very dense. It's written by quite a few people. A lot of engineers got together at Google. The one caveat to this book, though, is that this is SRE at Google. Google has Google problems. They don't have the same type of problems that the rest of us had. But there's a lot of really good stuff in this book. There's some stuff about error budgeting and, of course, MTTR and lots of different things. So if you're in that role of trying to keep systems up, I highly recommend picking up a copy of this. It's actually free. They made it open source, and it's under public license now. So I think it's just google.com/SRE book or something like that. But Google it. You'll find it, I'm sure. But this is a quote taken straight from that book, and from Benjamin Trainer-Sloss. The most relevant metric in evaluating the effectiveness of emergency response is how quickly the response team can bring the system back to health. And that is simply MTTR. And a lot of this has to do with just simply trying to keep systems up, right? High availability, high reliability. We want to have as close to 100% uptime as possible. This is sort of the edict that a lot of us are given, and it is the objectives that a lot of us in ops or a lot of us in SRE have. And this is sort of why DevOps kind of exists, right? Our developers are out there trying to push code, quality code, of course, and get it out into production. And the ops people were saying, hey, we're incentivized on keeping the systems up, so we're going to pump the brakes on this whole thing. And DevOps has sort of come around to sort of ease that tension and make things work a little bit smoother and deliver the services to the end users. So a lot of you, like me, probably think, well, if what we're trying to do is keep the systems up, shouldn't we be in more of a defensive tactic and defensive mode, just trying to protect the systems, trying to understand what may or may not be going on, and then try to react maybe beforehand? And so we take the stance of, well, maybe we want to predict things as best as possible and then hopefully prevent that stuff from happening. Because for you, how many people are actually on call? Is that part of your role? So none of us love to be paged in the middle of the night. It's like the worst part of the job. But still, we don't really have, in a lot of cases, we don't really have a lot of people to lean on. And DevOps is starting to sort of shift that a little bit. We talk about moving things to the left. Developers are coming on call now. And a lot of it, is just sort of there to be part of that empathetic message, right? And so, but anyway, back to the prediction and the prevention stuff. If that's sort of the tack you're going to take, a lot of people think, well, shouldn't we be trying to aim for this longer time between failures? Maybe we want to have like days between a failure or months between a failure. And so they aim to sort of engineer in solutions to just keep things from failing. And that's definitely the way I sort of looked at systems administration. It wasn't until I joined VictorOps that, well, up until then, I was a system administrator. Then I put the pager down, and I picked up the microphone, and life's been great since then, for the most part. But anyway, the meantime between failure was definitely the way I looked at it. But then I got involved with this sort of industry and this community and realized that we're not really building simple systems. We're not building even complicated systems in some cases. We're actually building complex systems. And in complex systems, there's a lot of unknown unknowns. There's things that you can't account for. There's things that you cannot predict. And so the main point is that failure will happen. Is there anybody who can tell me today that they work on a system that has never, ever failed, that they didn't build today? John Allspaw is another sort of, popular person within our industry, and he's written a lot of stuff. He's actually, one of the early DevOps people. If you've ever seen the talk, it's called 10 Deployments Per Day, when he was back at Flickr. I think this was around 2019 at O'Reilly, and this is sort of one of the things that really kicked off the whole DevOps movement. A lot of people didn't know that you could do that, or didn't believe that you could do that, this 10 deployments per day. But I love this quote from John. This is actually from his blog. It's called kitchensoap.com. I highly recommend checking it out. But John says, failure cares not about the architecture designs you slave over, the code you write and review, or the alerts and metrics you meticulously pour through. Failure happens. This is a foregone conclusion when working with complex systems. And that's definitely like some serious Kool-Aid that I drank on day one when I started working within this whole DevOps industry. I know for sure, as a former system administrator, as an ops person, that failure will happen. I tried really hard to prevent it, and I just couldn't. And so a lot of it is starting to make a little bit more sense now. On one of the blog posts that John has, and by the way, there are a ton of really good stuff in here about complex systems and sort of the fallacies of root cause analysis, which is a whole other talk that I'd love to give at some point. But he says, in here that it's not that mean time between failure isn't important. It's just that the mean time to recover is actually more important. And there's a quote in here. He's actually quoting someone else that says, "If you think you can prevent failure, then you aren't developing your ability to respond." And that's really true. I wasted a lot of time just trying to harden my systems and trying to keep things from happening. And I didn't even think about getting me and my team poised to respond and react and deal with problems very, very quickly. Whereas it's almost like if you think about sports, you go in and you rehearse and you practice and you do it day in and day out. That's why we have, failure injections and game days. We just want to get really, really good at responding to these problems because you can't prevent them from happening. But if we talk a little bit more about some of the, kind of popular O'Reilly books out there, this one's another really good one. In fact, a lot of this talk is actually just sort of a glimpse of my sort of reading habits for the past year or so. But mean time between failure comes up here too. It's sort of essential to understanding the availability of a service that you're building. And they state in the Effective DevOps book here that availability is commonly used measurement of how often a system or service is available. Mean time between failure, again, this is used to calculate this, but mean time to recover is also a big part of that. Availability and reliability is really just essentially the result of your teams being able to respond and recover really, really quickly. The DevOps Handbook, this came out late last year. It's another really good book, kind of the follow-up to the Phoenix project. It's mostly a lot of case studies. Throughout it, you're going to see a lot of different things. This is a page that I just happened to flip to that was talking about MTTR. If we heard from Bill at Puppet yesterday talking about the State of DevOps report. This is something that people they kind of have established as the de facto sort of metric when it comes to dealing with incidents. And one of the things that comes up, pretty much perennially in the State of DevOps report is that the high-performing organizations, the companies who they have sort of deemed these high performers, they're able to respond to production incidents very, very quickly and quite a bit more fast than some of their low-performing teams, 168 times in the most recent State of DevOps. And you can search the web. You can go on DevOps.com. You can search, a lot of Gene's writings. You can go on the VictorOps blog post. Everywhere you go, MTTR, MTTR, MTTR. That's what you want to drive down. Has anyone ever asked you this question here? Yeah. I get this question all the time, and this is my face every single time. What are you talking about? DevOps is culture. DevOps is a mixture of people and process and technology. How are you going to ever put a return on investment on something that has so much of it is just hinged on the cultural piece of it, which is just the people piece? It's very, very hard. How about this question? Has anybody ever asked you this? Some of you system administrators, some of you ops people, has anybody come to you, management, CEO, CTO, and say, what does it cost when we have this type of a problem? These are questions that some of us do kind of sit and think about for a little bit, but then it gets really depressing. So we don't really spend a whole lot of time about it. This is me when somebody asks that. I don't know. But thank you for the State of DevOps report. Again, every year this thing comes out, and there's lots of good stuff in here. But for the first time, 2016, they were able to talk about the return on investment of DevOps. And when I saw that, that's really the first time that sort of an established... Now, let me back up. I've seen lots of blogs, I've seen lots of articles, and I'm just like nodding my head, nope, 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 through most of those. But when it's the state of DevOps report, I kind of pay attention. I think they kind of know what they're doing. The people over at Dora, Puppet, Chef, all those people, they understand this stuff. And so when I saw that, of course, I'm like, chapter 20, let's get there. Here we go. ROI. Savings includes the cost of downtime and the cost of excessive work. So the very next page, I believe, is you'll find this sort of formula. The cost of downtime equals deployment frequency times change failure rate times the mean time to recover times the hourly cost. This is the first time, at least for me, that I've seen a formula that I can actually associate some real dollar value to some sort of a problem. And of course, at this point, I'm like, wait a second. Okay, here we go. Now we can start calculating some numbers. So let's see what we've got. If we look at the deployment frequency, the change failure rate, and the mean time to recover, we can actually start to see some real costs here associated with the outages. And they could be small outages, anything between a Sev 1 and Sev 5. Doesn't matter, but we can start associating some numbers. Well, let's unpack this formula a little bit and go through each of them one by one. Deployment frequency. This one should be fairly obvious. It's how many times per year does your own org deploy changes, or how often are you deploying new changes to the system and pushing things out. High performers are scoring at about 1,460 per year, whereas low performers more like 7 per year. How many of you feel like you're closer to the high performer? Lots and lots of deployments per year. And then low performers, don't be ashamed, it's fine. Change failure rate. This is another one too, and this is the one that really gets you in a lot of times, which actually is kind of a big part of why we lose confidence in our own ability to do those changes. When we have a lot of failure every time, or not every time, but often when we go to change, we tend to slow things down, and that's sort of counter to what we're actually trying to accomplish with DevOps. But the change failure rate is the percentage of changes that cause an outage of your organization, and then low performers have some kind of problem between 16 and 30%, whereas the high performers are more like 0 to 15%. And then the last two variables of that formula are the mean time to recover and the hourly cost of outage. Real quick, just on the hourly cost of outage, this one's probably the more difficult one to calculate, because then you start having to consider salaries and all kinds of things that you really have to get granular. You probably got to sit down with your CFO and a lot of different management and understand what is our daily cost in a lot of different ways, so we can start associating that with the actual downtime. Not to mention, sort of things like lost customers and bad PR and people going on Twitter and just, rambling on and on. But that's something you have to start looking into and see if you can understand it. And then, of course, the mean time to recover is, the theme of this talk. So, again, back into the state of DevOps, and I know this is really difficult to read, so I definitely highly recommend that you download it, take a look at it on your own. But they started putting some numbers here, and they sort of grabbed a larger organization here, and they said that using the lower number of costs of $500,000 per hour. Now, again, this may not apply to you if you're not in a larger company, but they use this as just sort of a general benchmark. And they were able to say that high performers with downtime cost them about $37,000 per hour, whereas the low performers was more like 2.8 million. Or I'm sorry, not per hour. So the numbers I wouldn't worry about too much here. This is really just to give you an example. And actually, I kind of consider just taking this out of this deck because it's a little confusing. But the point is that now you can start to see some real numbers and what they start to look like. But what is the mean time to recover exactly? What do we mean when we're talking about mean time to recover? Well, the DevOps report says, how long does it generally take for you to restore when a service outage occurs or an incident occurs? And that would be just your unplanned stuff, the things that you weren't really accounting for, not your system maintenance, not your planned maintenance, and that kind of thing. But what does mean actually mean? Because sometimes I think, we hear things, we agree, we nod, we move on. And, some of us may have studied some, math and did some things in college and that kind of stuff, but not everybody really pays that much of attention. So let's talk about mean just for a second. What we actually are talking about here is an arithmetic mean, the value obtained by dividing the sum of a set of quantities by the number of quantities in a set. Essentially, this is just an average. So we're relying heavily on a formula that's just providing an average for us. An average as a metric actually doesn't tell us a lot, doesn't tell us much at all about the individual incidents, and doesn't really give us a clear picture about what's going on. There's certain limitations with this type of number when it comes to averages. And one of those is that within the data set, they're skewed or where outliers are presented. Excuse me, I'm feeling a little tongue-tied. Calculating the arithmetic mean often provides a misleading result. So the main point is that it can't account for the outliers. There's going to be a lot of just really random stuff. There's going to be some really terrible outages, and there's going to be some little ones and some little dinky stuff that you're going to recover from very quickly. And when you're just purely looking at the MTTR, it doesn't have a way to sort of account for that. So you start to see this really distorted picture and an unclear view of what's actually going on when it comes to incident response and how quickly you can get your systems back up. Has anybody ever read a book called Thinking Fast and Slow by Daniel Kahneman? Awesome book, probably my favorite book that I've read in the past 5 years. It's very dense. I would actually recommend listening to it on audiobook. That's how I got through it. But one of the people in there that they talk about is this guy named Richard Thaler. And I'm actually in the middle of reading a book by him called Misbehaving. And it actually, while I was reading that book, is actually when I got the idea for this talk. And it was this quote right here, this little passage where he says, the number of data points, and he's talking about averages, the number of data points can vary greatly depending on the complexity and the scale of a system. Furthermore, averages assume there's a normal event or that your data is in a normal distribution. But anybody who's been on call knows that incidents aren't normal. There's lots of different things that can go wrong, and there's lots of different ways of sort of remediating it, and as a result, lots of different times that might come up in terms of how often or how quickly you can respond to that. So let's look at some actual numbers. These are customers of VictorOps. These are customers of ours who have 50 seats or more, so they have at least 50 people on call. Customers with 50 seats or more, they have 5,600 alerts per day. Now, an alert could be just an information alert, it could be a critical alert, it could be a warning alert. But again, this is an average. And the reason why I wanted to point this out here is that 5,600 alerts per day. Can you imagine your company having 5,600 alerts and you're the person on call to deal with that? That's too much. And the reason why this is so high is that we've got a few customers who have very noisy infrastructure. They've got a lot of alerts, and it's throwing the whole thing off. Same data set, we've got 66 incidents per day. These are critical incidents. These are like at least Sev 3 probably or higher problems that people are having. And again, this is an average. So 66 critical alerts per day, that's something that seems kind of incredible. So I threw this in here just, again, sort of highlight some of the flaws when it comes to like using and leveraging averages. This histogram here shows one of our customers. Their mean time to recover is 40 hours. That's a lot. It's a really, really high number. But it looks like actually a lot of their incidents are recovering quite quickly. It's just that they've had a number of incidents that took a very, very long time, which completely skewed that MTTR. This, to me, is a huge problem if I'm trying to use MTTR as a way to establish a cost of downtime or anything important at all. We advocate for paying very close attention to the MTTR and drive that number down. That's part of your continuous improvement plan. But if your number is at 40, and that's not really very accurate, it kind of, I guess, begs some question as to what are you trying to do. And there's lots of reasons why that number could be high, or there's lots of reasons why that number could be low. In this case, the ones where we saw it kind of skewed to the left, where there's a ton of them, there may have been a lot of incidents that were just auto-resolving. Nagios or whatever you're using, Datadog, may have picked up that there's a problem. Before you even had a chance to acknowledge it, it had already resolved. That happens a lot. Engineers, sometimes I'll get paged, and I'll look at it. This isn't something I know how to do. I'm just, I was the poor schmuck who's on call, but I'm going to hand this off to the person who actually knows how to deal with that. So I'll just go ahead and reroute, and that's going to add more time. The clock's ticking as soon as that incident's created. This one I actually love. It's a little bit sort of controversial, I guess, but a lot of companies, they won't resolve an incident until they have completed their postmortem. Now, someone who loves the idea of postmortems, I like that idea because it kind of holds you responsible to sit down and let's talk about this and try to improve things right now. But then again, your clock is still ticking that entire time. And then there's also this situation. How many have just had some sort of, I don't know, maybe it's your data center, maybe there's something going on and you're like, I know, and you just keep clicking resolve. You're just like, I know, Amazon's down again, it's fine. It's going to be back up. We're going to move on. We're still going to use Amazon. It's fine. tire fires are just part of the job when you're on call. And these like major outages, these Sev 1, Sev 2 things, if it's an extended outage, this can really throw off your data. It can really extend your mean time to recover and start to sort of muddy up the data, muddy up the number. Okay, so if all that's, hopefully you kind of, you're jiving with me, you understand where I'm going with this whole thing. If that's the case and MTTR isn't, perfectly accurate, what should we be measuring? What's something else? Well, median is very, very helpful when it comes to sort of dealing with those outliers. Now, median is still not perfect, but at least it's something. It's definitely a lot more robust to those outliers. Maximum time to recover, that's another one. Probably not as important, but I think it is sort of, interesting to keep an eye on. How long does it take you to recover? Not necessarily on average, but what's the longest it's taken us? Let's keep an eye on that and try to keep that number going down. The volume of alerts. Okay, the severity. How many like Sev 3s are we getting? How many Sev 2s? Sev 2 is something that actually affects the bottom line, affects the revenue. How many of these are we seeing? Are you keeping track of how many of those are happening on a day-to-day basis, week-to-week, or whatever the case is? Total number of outages. This is going to be something that's important to you if you have service level agreements. You probably, have to try to hit that 5 nines, 3 nines, whatever the case is, or maybe you've just got a total number of downtime or total hours of downtime that you're trying to maintain. Maybe you got some flappy infrastructure in there. There's something just going crazy all the time, and it doesn't seem like you can do anything about it. You twist all the thresholds all the time, but you just got noisy hosts and services. This is another one I think a lot of people don't pay much attention to. How often are you paged, and it's something that you can't do anything about? That's super aggravating when it's 2 or 3 in the morning, you get that page, one eye open, you're looking at your phone, nothing I can do about it, or it's just not that big of a deal. The hard disk reached 97%. That's great. It's Saturday. They're running reports. It's going to clear itself out. It's going to be fine in 5 minutes. I don't want to be paged on that. Are you keeping track of the unactionable alerts? Also, just the different types of alerts. How about your informational alerts, your critical alerts, your warnings? How many of those are you seeing? It's important to know how many of them are just simply warnings, and sort of start, twisting, tweaking those dials and try to get things a little bit less noisy. The alert volume per day. Now, again, we're back to another average. I always have to say, be careful of this, but what is your alert volume per day? How often are you being alerted per day? That is something you should pay attention to. What time of day? Are you being paged only during office hours? That would be awesome. Are you being paged only in the middle of the night? That wouldn't be as great, but that seems to be sort of the case in most points. But again, keeping an eye on when are you being paged? When is things going off? Is something you should be paying attention to. The mean downtime. This is actually something that until I started putting this together and trying to think of some other things that might be interesting, I hadn't really considered too much. But the mean downtime, what is that? Mean time which the system is down after a failure. Mean time to acknowledge. This is an obvious one. How quickly are you able to actually just acknowledge that you're going to be the one who's responding to this issue? Biometric data. We experimented at VictorOps for a little bit with those of us who had the Apple Watch. What did our heart rate do when we got paged? It always goes above 100. How about sleep disruption? Etsy's kind of famous for their mean time to sleep. They wear Jawbone or something on their wrist when they're sleeping, and they track that data. This is for real. They know how much of your REM sleep is being disrupted simply by being on call. They take a very humane approach to just the role of being on call, which is something all of us should try to learn from. All right, let's get into my final thoughts here. I've got about a minute left. One of the things I can definitely advise is to identify your noisiest alerts and try to address them right now. Don't wait, because it's not going to go away. Just address them right now. Bring more people in the fold. We talked to a lot of people at the VictorOps table yesterday and today. We asked them, are you on call? And they said, no, I'm a developer. Okay. Share the load. That's just part of the bringing more people. Shift everything to the left. Let's all understand what's going on. Let's share this. We're building a service. We all are service providers. We're building this together. Share the information. These are just sort of basic DevOps tenets. The CAMS model, culture, automation, measurement, sharing. Share the load, share more information, share the knowledge across things. You can respond and recover much quicker that way. So here's my challenge to you as we're wrapping up. Examine your own mean time to recover. If you haven't started paying attention to that, try to start tracking those data points and see where you're at. And discuss that. And discuss, could this data be skewed? And are we maybe not understanding it in a very clear way? Be very careful of incentive structures. As you know, anything that can be measured can be gamed. So if you tell me I have to hit a certain number, I'm going to hit that number. That's something that happens all the time. I don't think we realize it. So the efforts that we're putting to actually improve things may actually not be happening at all. So what's the cost to you, to your organization, by not paying attention to this type of stuff? Or maybe you are. Maybe you're very diligent about that MTTR, but it's actually not telling you what you need to know. And then you're going to be the hero. You're going to be able to take your butt up to management and say, look, I've figured out the ROI of DevOps. This is that one thing that you asked for, long time ago, and I think I've got it solved. So, one more thing. This is sort of my main message when it comes to any of my talks, and especially anything about DevOps, is that it's really just the idea of continuously improving everything. So, whether it's your MTTR, whether it's just your automation, whether it's your pipeline, whether it's, learning new tools, whatever it is, don't try to boil the sea, don't try to boil the ocean, just make it small and try to just constantly improve over time. And all these things, CI, CD, automation, everything, all that seems to just fall in place. They're all just a byproduct of having a very, very strong focus on continuously improving everything that we're doing. That's all I've got. I appreciate it. It's been awesome being up here in Vancouver. And if we've got time, we'll do questions. Otherwise, we'll get started with the open spaces. We can do them there. Thank you so much. Oh, one other thing. I forgot I threw this up here. It's April Fool's Day, most of us probably know, and I just happened to get an alert that we had posted a new blog post today on MTTR. And so if you get a chance, I couldn't obviously squeeze it all in here, but you should go read this. It's kind of funny on the VictorOps blog, but it's an April Fool's joke for sure. Yeah. Do we have any questions? Oh, awesome. That's my favorite. Oh, there's two. Yeah. So when you're assessing the cost of downtime, how do you go about assessing modeling losing a customer? Yeah, that's a really great question. I don't know that we at VictorOps have ever done that. I'm not sure I've ever. The one thing I will say that we and a lot of companies that I've talked to is we've got some sort of response plan in place. So we have a status page. We can immediately let the people know that need to know what's going on. That can be internally. That can be our customers. We've got our marketing team. They're always on call and ready to start posting on Twitter and wherever else to let people know, hey, we've discovered a problem. We're investigating. Keep paying attention here, and also on our status page. It's sort of that proactive approach. But beyond that, I don't know that I've got any really great suggestion on sort of modeling it or even tracking it. I mean, we definitely know when we lose a customer because of some reason. Customer attrition is something that somebody's paying attention to, I guarantee. But beyond that, I don't know I have any great specific examples. Is there another one? No, same one? Okay. All right. Well, again, thank you so much, and let's get started with the open spaces, I guess.